JavaScript is a programming language that you can use to add interactivity to your web pages. You'll often see JavaScript referred to as a scripting language, with the implication that it's somehow easier to script than it is to program. That turns out not to be a useful distinction because it's all programming. A JavaScript script is a program that is either contained internally in an HTML page, which was the original method of scripting, or it resides in an external text file, which is the now preferred method. An external JavaScript is a text file that has the file extension .js. So here's another buzzword that we should get out of the way. JavaScript is an object-oriented language. So what does that mean? Well, we tend to think of it as a language made of building blocks that you can snap together to make things happen on your web pages. An object is some kind of a thing. In the real world, books, bicycles, and cats are all objects. In the JavaScript world, which is mostly a world within a web browser, objects include windows, buttons, and form fields. You manipulate JavaScript objects with the language. If you want to work with more than one object at a time, you can combine them to create new objects that JavaScript deals with as a single object. So let's talk about how you would snap together objects to create other objects. Well, like we said, objects are things. In this case, this particular object is our excellent cat pixel. Objects have properties. A cat has fur. Obviously, the cat has fur. And some other examples are that books have pages and a bicycle has wheels. In the JavaScript world, a document has a title and a form can have a checkbox. Note that the book's pages and the bicycle's wheels aren't only properties, they're also objects in their own right, which can have their own properties. So objects can have sub-objects. Our cat has some sub-objects of his own. A tail, his head, and his 4 paws. I could actually define many more of his sub-objects, but you get the point. The things that objects can do are called methods. Cats can do a variety of things. They can purr or stretch, and they're especially good at sleeping. In the world of JavaScript, you can have windows that open, buttons that can be clicked, and text that can be selected. Notice that the parentheses signal that we're referring to a method rather than a property. If you want to describe more than one object, you can put together objects, properties, and methods to get a better description of an object. In JavaScript, these pieces are separated by periods, also known as dots, as in internet addresses. This is called dot syntax. Here's a couple of examples of objects with their properties. In this case, there's computer.drive.dvd or window.status. And here are some objects with methods. cat.purr or document.write. So let's build a whole object example. Reading left to right, the properties get more specific as we build the object. So we begin with cat, we add paws, we specify front, and finally the right paw. So that's all you really need to know about dot syntax for now. And if you'll excuse me, I've got somewhere to be. Events are actions that the user performs while visiting your page. Submitting a form and moving a mouse over an image are 2 examples of events. The JavaScript language deals with events using commands called event handlers. An action by the user on the page triggers an event handler in your script. There are 12 common JavaScript event handlers, as shown in Table 1.1 in the printed book, and also on this slide. You might want to pause the video for a moment to read all of these. They're pretty self-explanatory. When you write a script, you don't have to anticipate every possible action that the user might take, just the ones where you want something special to occur. For example, your pages will load just fine without an onload event handler. But you need to use the onload command if you want to trigger a script as soon as the page loads. Let's see a quick example of how one of these event handling scripts works. Here we are in our preferred text editor on the Mac, BBEdit, made by bare-bones software. As you can see, it does a nice job of coloring the different parts of the script. For this example, we're looking at a script which is inside an HTML page. We're doing that here only because it's easier to visualize what's happening. However, we don't suggest that style of scripting in general. It's far better to separate your HTML and JavaScript in separate files, with the HTML calling the JavaScript file. It makes it much easier to maintain your JavaScript and allows you to easily reuse the same JavaScript on multiple HTML pages in your site. Let's take a look at the script. When the page loads, this script block executes, writing the phrase "Hello World" into the body of the document. That's what it means when it says document.write. If the user clicks in the body of the document, this on-click event handler fires off and will pop up an alert box. Let's see this in action. Okay, so here's the page in Safari. And if I click here, nothing seems to happen. That's because we're not actually in the body of the document. The body of the document isn't the whole window. It's actually only the part of the document that's specified by the HTML page. So if I click on the part that is part of the body, the Hello World part, we'll get that alert box that we saw in the script. You can see it says JavaScript ouch. And that's exactly what was called for in the body statement inside the script. Now that you have variables, you're going to want to work with them. Operators are the symbols that you use to work with variables. You're already familiar with operators from simple arithmetic. Plus and minus are operators, and they're specialized operators that are in JavaScript that we'll see a little later. You can use operators to compare the values that are contained inside variables. Let's see what it looks like to work with operators inside a browser. We've set up this web page to use the operators in the middle of the screen to compare the values in the value 1 and value 2 fields. Let's give it a shot. If in value 1, I put in a 1, I tab over to value 2, and also put in a 1, and then I choose the equals sign, which means exactly equals, and then tell JavaScript to evaluate, we get a result. It says you checked if 1 is exactly equal to 1, and the result was true. So now let's look at the bang equal, the exclamation point equal, usually known as bang equal. That means not equal. And we'll evaluate that. The result in this case is that we check to see if 1 is not equal to 1, and the result was false. If we change the value of value 2 to, say, 23, and evaluate that, without changing the operator, we can see that 1 is not equal to 23, and that value is true. If we go back to the equals, checking to see if 1 is equal to 23, it turns out that's false. You can get the same kind of things with the less than and greater than. But this doesn't just work with numbers. This also works with strings. So if I type hello world, and I choose the equals operator and click evaluate, it turns out that hello and world are not the same thing, and the result is false. Checking to see if they're not equal to each other, and that result is true. Now here's something that's a little interesting. Let's go back to the equals comparison, and I'll type in hello over here, and I'll click evaluate. Now this evaluates as false because hello with a capital is not equal in terms of JavaScript to hello all lowercase. But if I choose the not equals and evaluate, that result is true. You'll use these comparison operators often when you're JavaScripting, so it's a good idea to get very familiar with their use. In JavaScript, a piece of information is a value. There are different kinds of values. The kind you're most familiar with are probably numbers. A string value is one or more characters, such as a word or any alphanumeric character or multiple words, enclosed in quotes. A Boolean value can either be true or false. The null value is just that. It's a value that's completely empty. The null value is usually a starting point that gets filled by your script. The value of an object can be any value that is assigned to that object. And finally, a function value is the result of a function. We'll go more into functions a bit later. Variables contain values. They can be any of the value types we just discussed, and you can name them as you like, subject to a few rules. You can create your own. One of the rules that you need to worry about is that variable names are case sensitive, so all lowercase my name and the camel case my name, as shown here on the screen, are different. Variable names can't contain spaces, punctuation, and they can't begin with a digit. They also can't be one of JavaScript's reserved words, and you can easily find the reserved words online. Do a Google search for JavaScript reserved words, or they're also in an appendix at the back of our book. You assign a value to a variable using the equal sign. So in this example, the variable my name is assigned the value Tom. Now, Tom here is a string value, and you can tell because it's enclosed in quotes. It's important to understand that modern web pages are made up of at least 3 documents. What you want to do is write modern, standards-compliant HTML and use CSS to style the page. Then you add 1 or more JavaScript files to drive the active behavior of the page. To illustrate that, let's take this page from the companion site from our Dreamweaver book. This web page is actually created from 3 separate documents. The structure and page content is contained in an HTML5 document, which is what we suggest for all your pages. There's enough browser support now that older versions of HTML just aren't necessary. In this structure, you're going to use block elements such as div and span to identify and manipulate your content. The presentation of the page comes from the CSS file. That contains the styles rules that define how the divs and spans should be displayed in the browser. You'll use classes, which can be reused within a single page, and IDs, which must be unique on the page, to identify each block element. The behavior of the page comes from the JavaScript file. You can use JavaScript to zero in on the style or block elements on the page, and use it to change the way those elements act in the browser. When you separate the 3 main components of a web page, it makes it easier to maintain your website and to reuse work that you've done for one page on other pages throughout your site. You'll often want multiple HTML pages to share a script. You do this by including a reference to an external script, which is a separate file that just contains JavaScript. This external file is called a .js file because the file name should end with the suffix .js. Individual pages call the .js file simply by adding a new attribute, source src, to the script tag. This saves a lot of code on every page and makes it much easier to maintain your site. When you need to make changes to a script, you just change the .js file, and all HTML pages that reference that file automatically get the benefit of your changes. Let's take a look at how to call an external script. Here's a simple HTML file. As you can see, inside the script command, there's script src equals open quote script02.js close quote, and then the script tag closes. Down in the body, in the H1, there's an ID of hello message. We'll see that in a moment. Now let's switch over to the script02.js file. Okay, here it is. The script starts with an event handler, window.onload, and it calls the write message function. Below that, we see the function, and the function contains document get element by ID hello message. Then it uses .innerHTML, which is actually telling JavaScript what to put inside hello message, and it's going to put in hello world. Let's go back to the original HTML page, and we'll preview it from right here in BBEdit. And you'll see that the web page does exactly what we said it was going to do. It just prints out hello world. So what we've seen is how we can take an HTML page and link it to an external script. Let's learn a little about JavaScript functions. A function is a set of JavaScript statements that performs a task. Every function must be given a name. The function can be invoked or called by other parts of the script. Functions can be called as many times as needed during the running of the script. For example, imagine that you have several buttons on your web page. Each time a button is clicked, something happens on the page. You could create one function for each button, but it's much less complex to write a single function that gets called for any button that gets clicked. Here's what a function looks like. It consists of the word function, followed by the function name, which is say something. There's always parentheses after the function name, followed by an opening brace. The statements that make up the function go on the following lines, and then the function is closed by another brace. Notice that the line with alert is indented. That makes it easier to read your code. That semicolon at the end of 7 years ago tells JavaScript that the line is ending. All of the statements between the first brace and the last one are part of the function. You probably notice that those two lines aren't indented. And that's all you need to know for now about functions. It's a good idea to get into the habit of adding comments to your scripts. You do this by inserting comments that JavaScript won't interpret as script commands. While your script may seem perfectly clear to you when you write it, if you come back to it a couple of months later, you may not be able to figure out just what you coded in that 2 a.m. frenzy of creativity. Comments help to explain why you solved a particular JavaScript problem in a particular way. Another reason to comment your script is to help other people who may want to reuse and modify your script later. There are two kinds of comments in JavaScript, long comments and short comments. A long comment allows you to make a comment that's more than one line long. A short comment fits all on one line. We have both kinds in this document. For the long comment, you start it with a slash and a star, or a slash asterisk if you prefer. And then you can see that we have 2 lines of comments here. In fact, they're so long that they extend off the side of this window. And then we tell JavaScript that the comment is ending by doing the reverse, the asterisk slash. For the short comment, you simply add 2 slashes and then a space, and then JavaScript ignores everything after that, interpreting it as what it is, the comment. You can see that the comments in this script tell you 3 things. 1, the long comment at the start tells you what the whole script is about. 2, the first short comment, the one after the window.onload event handler, tells you just what that one line is doing. And then the third short comment tells you what the function write message does. So that's the long and short of commenting in JavaScript. When you need to provide feedback to people browsing your site, JavaScript can help by allowing you to pop up alerts, confirm a user's input, and prompt the user for input. You can create an alert window that pops up and gives users the information that they need to know about your page. This could be an alert that they haven't filled in a form correctly, or it could be a notice that triggers when they try to leave a page on which they've entered text, warning them that their changes will be lost if they navigate away. Let's take a look at this simple alert. When I reload this page in Safari, we get this simple alert box. Welcome to my JavaScript page. Note the indication telling the user that the alert box was put up by a JavaScript command. This is a security feature built into browsers to keep unscrupulous scripters from fooling naive users. You can't code around this. Now, let's take a look at the code behind that example. The HTML is pretty simple. All it does is call the external JavaScript file. Notice that it also has the noScript tag, which only executes if the user has a browser with JavaScript turned off. In this case, the page ends up saying that the page requires JavaScript. We won't see this because obviously we have JavaScript turned on. In the external .js file, things are just as uncomplicated. All we need is the alert statement with the text of the alert inside the parentheses and within those inside double quotes. As usual, at the end of the line we put in a semicolon to tell JavaScript that the line is over, but that strictly isn't necessary in this case since there's only one line in this script. Sometimes you want to get information from the user, so you're going to want to put up an alert with more than one choice. Let me reload this page and show you what I mean. In this case, we're just going to use the default OK and cancel buttons in the alert and interpret OK as yes and cancel as if the user said no. Let me show you that. And JavaScript tells us you said yes. If I reload the page and click cancel, JavaScript says you said no. Now, we'll skip looking at the HTML for this example, as it looks pretty much like the one from the last example. All it does is call the external JavaScript file. So, speaking of which, here's the JavaScript file. Now, this script introduces the idea of conditionals, which is where the script poses a test and performs different actions depending on the results of the test. Conditionals break down into three parts. There's the if section, where we do our test, the then section, where we put the part of the script we want to do if the result is true, and an optional else section down here, which contains the part of the script we want to have happen if the result of the test is not true. The contents of what we're testing in the if section are in parentheses, and the contents of the other two sections are each contained in curly braces. The curly braces define the beginnings and ends of the different parts of the conditional. Now, there's no then operator in JavaScript. It's implied if the result of the confirm method returns true as its result. That's why the alert says you said yes if the user clicks the OK button. So this line here, from this bracket down to the end, which is highlighted, that's actually the then section of the script. Now, the else section only happens when the user hits the cancel button. Then the second alert, the one that says you said no, fires off. There's an alternate method of writing a conditional that takes a different form. Let me show that to you. In this case, you have condition in parentheses with a question mark, and then there's the true part, a colon, and the false part. That's kind of the rough equivalent of if condition, then true part, else false part. The point that I'm trying to make here is that there isn't just one right way to code things in JavaScript. Once you get familiar with the language, you'll be able to do things in the ways that make the most sense to you. When you want to get some specific information from the user, rather than just a yes or no answer, you'll need to prompt them for that info. Let me show you how that works. If I reload this page, a prompt comes up that says, "Are you sure you want to do that?" And I'll answer it. JavaScript took what I typed into that prompt dialog and then gave it back to us in this alert dialog, which demonstrates that JavaScript stored the result of what I typed in. Let's look at the JavaScript that makes that happen. We start by declaring a variable called ans, short for answer. We use the var keyword to declare variables. Now the variable uses the assignment operator, the equals, which is the content of whatever the user types into the prompt dialog. The prompt method is passed two pieces of information, which are called parameters, separated by a comma. The first parameter is the question for the user and the default answer. It returns either the user's response or the result null. Null occurs when the user hits cancel, or when there's no default and the user hits OK, or when the user clears the default answer and hits OK. And the two quotes with no space in between them indicates null. Now this conditional here uses the variable ans that we just set. If ans exists, that is, if the user typed in a response, then the script puts up the alert window that says, you said, and let's note that there's an extra space here at the end of the text string so it looks good, and it uses the concatenation operator, the plus, to append the value of ans to the end. In the else section, if ans was null because the user didn't enter anything or click the cancel button in the prompt dialog, then the else block of the condition is executed and the alert pops up saying, you refused to answer. So that's the beginning pieces of how to interact with the user with JavaScript. There's lots more of that to come in future videos. Programmers often need to test for a particular condition and repeat the test as many times as needed. The program structure that we use in JavaScript to do this is called a loop. A loop repeats an action a specified number of times. The kind of loop we mostly use in these examples is the for loop, named after the command that begins the loop. This sort of loop uses a counter, which is a variable that begins with one value, usually 0, and ends when a conditional test inside the loop is satisfied. At that point, the program drops out of the loop and continues on with whatever instructions are in the rest of the script. The command that starts the loop structure is immediately followed by parentheses. Inside the parentheses, you'll usually find the counter definition and the way that the counter is incremented. In this and the next few examples, we'll use a bingo card as our sample application. So here in Safari, here's the bingo card. You can click items in the card, but nothing happens yet because we haven't quite wired that up. This is just the bare framework of the card. Let's begin by taking a look at the HTML that creates the bingo cards framework. So here we are in BabyEdit looking at the HTML. As you can see, most of this HTML page is a table. The first row of the table contains the letters at the top of the card, the B-I-N-G-O, and each subsequent row contains 5 table cells, each with their own ID. To begin with, most cells contain just a non-breaking space. That's that HTML entity here, the ampersand MBSP with the semicolon after it. But if we scroll down the page, and we look at the third row, we can see that it contains the free space, so one table cell contains the word free. All the way down at the bottom of the page, there's a link that generates a new card. Now let's take a look at the JavaScript that generates the contents of the bingo card with the randomly generated numbers. This first line uses the window.onload event handler to call the initAll function. Down in that function, this line begins the loop. Programmers traditionally use the variable I to denote a variable used as a counter inside a loop. The first thing that happens here is that we set I to 0. The semicolon signifies the end of that statement and allows us to put another statement on the same line. So this next part here, you could read that as, if I is less than 24, do the following code inside the braces. and that would be the braces from here through here. The last part of this line increments the value of I by 1. That means the loop will repeat 24 times, and the code inside the loop will execute 24 times. Inside the loop, we create a new variable called newNum, and fill it with the result of the calculation on the right side of the equal sign. Let's start from the inside and work our way out. The math.random command gives us a number between 0 and 1. We take that result and multiply it by 75 because the values in bingo cards can be from 1 through 75. That gives us a result between 0 and 1 less than the maximum value because JavaScript begins its numbering at 0. The math.floor command gives us the integer portion, and we add 1 here at the end of the line in order to get a number between 1 and our maximum value. This next line writes into the table the value of the random number that we just got. We get the element with the ID name square with the current value of I concatenated onto it. For example, the first time through the loop, the value of I will be 0, so the line gets the element with the ID of square 0. Then the line sets the inner HTML property of the current object to the current value of newNum. The loop repeats until the whole bingo card is filled out. In JavaScript, an array is a kind of variable that can store a group of information. Like variables, arrays can contain any sort of data, text strings, numbers, or other JavaScript objects. You declare an array with the elements of the array inside parentheses separated by commas, like this. In this example, the array contains 3 text strings with different car makes. To access the contents of the array, you would use the variable name with the index number of the array member that you want to use in square brackets. New cars, bracket 1, close bracket, has the value forward because array numbering, like most things in JavaScript, begin with 0. Now, notice that in this example, we're using text strings as elements of the array. Each text string needs to be contained within straight quotes, and the commas that separate each element of the array go outside of the quotes. You can use JavaScript to control the CSS that defines the visual look of the page. In this example, we're using JavaScript to change the background color of cells in the bingo card that the user selects. For example, here, 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 here. When the user gets a bingo, that is 5 in a row, we use a combination of JavaScript and CSS to flash the winning squares and let the user know that they've won. You can also use arrays to work with text strings. In this buzzword bingo game, we're filling the bingo card and the bingo array with text strings rather than numbers. We've personally used this example for Apple keynotes, political debates, and simply to poke fun at words in general. Let's see if I can win this bingo game with the proper choice of buzzwords. Proactive, tipping point, user-generated, always a good one, mashup, impact, long tail, tagging, vlog, Ajax, paradigm, always facilitate, and we may as well go with beta as well. And it looks like I'm completely buzzword compliant. Rollovers are among the most common uses of JavaScript. The idea behind rollovers is simple. You have an original image that's loaded and displayed along with the rest of the web page. When the user moves the mouse over the image, the browser quickly swaps out that image for a replacement image, giving the illusion of movement or animation. Let's take a look at an example in Safari. Here in Safari, when I move the cursor over button 1 or button 2, they change colors. One method of approaching a rollover is to leave the replacement image on the server until the user moves the mouse over the original image. At that point, the browser fetches the replacement image from the server. But that has the possibility of creating a delay while the replacement image loads, which isn't very fluid from a user interface standpoint. It's better to get JavaScript to preload all of the images you might need for your rollovers, holding the replacement images in reserve, as it were, until they're needed. Let's take a look at the HTML needed for this particular example. We've got two main things going on in this HTML page. The highlighted line is simply the call to the external .js file. Down in the body section, we have two link tags for the buttons. Each of those link tags have image tags embedded inside them. The href attribute describes the destination of the link when the user clicks it. Inside the image tag, the source attribute provides the path to the image before the user rolls over it. Because it's good coding practice, each of the href tags also has an alt attribute, which is button 1 and button 2 here. Each image also has an ID attribute, which is important because the JavaScript will use that ID to make the effect work. Let's note those right now. It's ID equals button 1 and ID equals button 2. Here in the JavaScript file, we begin with the window.onload event handler, which triggers when the page is finished loading. This handler calls the rollover init function. Moving to that function, it uses a for next loop to scan each image of the page, which is what this line does. This line here begins by setting the counter variable I to the number of images in the document. Each time the loop goes around, if the value of I is less than the number of images in the document, it gets incremented by 1. And you can see that it gets incremented by 1 because it's I++. The plus operator increments the variable by 1. Beginning in the next line, we want to see if the tag surrounding the image is an anchor tag. We do that with an if conditional. Document.images_I denotes the current image. Its parent node property is a container tag that surrounds it, and tag name provides the name of that container tag. We're using the equals comparison operator to see whether or not that tag name is an A or an anchor tag. Equals, as you remember, means that it has to be exactly equal to. If the results of the if test are true, then we call the setup rollover function and pass it the current image, which is stored in the variable I. The setup rollover function adds two new properties to the image object that's been passed in. The new properties are outImage, which is the version of the image when you're not on it, and overImage, which is the version of the image when the mouse is over it. Both of these are image properties, so we can add and set their source properties. Is the off image the source property for the source value for over image is calculated based on the ID attribute of the original image. This line here takes the image object that was passed into the function and adds the new out image property. What's happening here is that we're adding an image object to an image. The second line that's highlighted here sets the source for the new out image to be the same as the source of this image. That makes sure that the default image on the page is always a version you see when the cursor is off the image. In this line here, we create a new image object that will contain the over image version of the image. Then, the second line sets the source for over image. It does this by building the name of the source file on the fly, concatenating the images with the ID of the image, and adding on.gif. This final function tells the browser that when the user moves the cursor over the image, it should reset the current image's source to that of the over-image version. So that's how you create more efficient rollovers, by preloading the images and having JavaScript swap them in entirely within the user's browser without needing to fetch the alternate image from the server. A three-state rollover is one where the rollover has three versions instead of just two. In addition to the original image and the alternate image that appears when the user places the mouse cursor over the image, there's a third version that appears when the user clicks the image. Let's check that out in Safari. As you can see, this looks like the previous rollover example. We have the blue buttons for the off state, the red buttons for the on state, the over state, and then when I click the mouse, we get green for that third state. When I roll off the button, it goes back to the original state. Same thing happens with button 2. I'm off, I'm over, I'm clicked. Let's take a look at the HTML. One of the nice things about the approach we're using here, and remember, there's always more than one way to do things in JavaScript, is that the HTML page has only the most minor changes from the previous example. All we've changed here is the title and the destination of the script tag. So now let's take a look at the JavaScript for this page. Here in the JavaScript file, it also looks similar to our previous example. Let me scroll down the page a bit, and we'll check that out. Where before we had 2 states to our setup rollover function, now we have 3, and all we needed to do to account for that third state is to add this section to the setup rollover function. As before, it builds the URL for the image used for the button state on the fly, except this time it adds click.gif to the end of the source statement instead of on.gif. The new block that we've added also includes another anonymous function, which is triggered using the onMouseDown event handler. That's similar to the other 2 anonymous functions, which handle the other states, onMouseOut and onMouseOver, as we've seen before. So you can see that building 3-state rollovers is fairly easy, simply by building on the regular rollover framework that you're already familiar with.